Yes.
Where application circular statistics for documentary surface area or area related to circle or area related to circle camera or button. अच्छा लास्ट नहीं कराया था सीधा लास्ट एग्जाम
So I think what were we doing? You're revising the topics or sources of energy. I come here to teach sources of energy, but I'm teaching something else, right? Okay. So what were we supposed to discuss today? Sure. Okay. If you have any doubts, yeah, ask me. So I'll also touch upon sources of energy, right? Like what? Can we live without energy today? No. Can we? Huh? In old days, how did we fulfill our energy needs? Through sun, right? Fire. What else? To cook food, what we used to do? Fire, right? So we were burning woods, etc. Right? Very, very primitive way of living. Burning woods, coal. Okay. So these types of energy, and more recently we had coals, then we had petroleum products, right? Petroleum products. What are petroleum products? What are they? Fossil fuels, and so they're also called as fossil fuels. This is not going to come in exam. Just that I should not start feeling guilty that I did not teach you this. So I'm just touching upon it. It's good to know for general knowledge, right? So what is fossil fuels? These are petrols, diesel. Let's check this spelling, diesel. Okay, so all these are all fossil fuels, right? And you should know what do you do? How do you achieve energy out of it? By burning, right? So when you're burning it, what are you doing? See, we may need energy in a different form, but it may be available to us in a different form. So we achieve energy through a process of conversion, right? So when we burn, which energy is getting converted from what to what? Big brain.
Is converting into mechanical energy.
Oh,
Light.
heat and light, right?
Heat energy.
Heat and light, right? But which energy is getting converted? Stored energy in the wood is in the form of chemical energy, right? So it is chemical energy. Right? So chemical energy is getting converted into heat and light energy. Okay? Whenever you burn anything. So in the process, do we get full chemical energy getting converted into heat and light? No. So there will be some energy which will be wasted. Okay? So because during the burning process, there is something called as combustion. So it will not be fully burned, right? Some residue will be there. So when the object or these fuels are not fully burned, right? They will release what? Carbon and certain oxides, okay, which will pollute the environment, right? So it all depends on the efficiency of the combustion process, right? So in automobile, you have engines, right? So what is done is the petrol or diesel is burned, right? And what do we achieve there? We are converting chemical energy into heat energy, which then operates the cylinder piston arrangement. So that is converted into mechanical energy finally. So chemical to heat to mechanical. So 3 times, right? So mechanical means then we get the motion. So piston vibrates up and down, right? So you have a piston which vibrates. So there is this kind of arrangement, right? So when this piston goes up and down, so this wheel turns, and then this wheel is connected to axle and tires of the automobile. Okay. So there could be like multiple 3-cylinder, 4-cylinder, right? Engine. You must have heard about it. So basically, this process is taking place. So in higher standard, you will be learning about heat engines. So this is the basic element of it, right? So chemical to heat to mechanical. That's the process. So basically, during energy conversion, some energy is lost. So the efficiency will depend upon the efficiency of the process of conversion, right? So what is most efficient or most used energy these days? The energy which is most used is electricity, right? In nature, energy is available in these forms, but we produce electricity. So we have power companies. So how do we produce electricity? So what are the methods? So we have hydroelectricity, right? So hydroelectricity is produced through dams, right? So what do we do in dams?
We use the force of water to generate electricity with the help of a turbine.
Correct, right. So we have a dam. So this is a water reservoir, right? Reservoir. So there is a flowing water which is held back behind the wall of the dam, right? So the height of the water increases. So it has mgh. So the flowing water had kinetic energy. Now it is held back, so it has potential energy, right? Now we'll have water gates. So the waters will be released from height. So it will have kinetic energy, right? And then this flow of water will hit the turbine blades. Okay, which is then connected to generator. Right? Generator. So generator or dynamo. So generator or dynamo is the device which produces electricity. So what you get in these 2 points are called AC mains. Right? So one is live, other is neutral. And there is one connection which is earth. Okay, earthing. So what is the potential difference between these two? If this is 0, this should be 220 volts. So in AC mains, what is the potential difference? 220 volts. Okay, like if you use cell in your house or in your torch, what is the cell potential difference? 1.5. So 1.5 volts. Okay, cell potential difference is 1.5 volts. It can go up to like 3, 6, like that. Okay, so this is what kind of potential difference? DC. What you have is AC, right? What is the difference between AC and DC? So we started coming into electricity, right? So potential differences, one is at a higher potential level and the other one is at lower potential level, right? So one has efficiency of electron, one has excess of electron. So how do we get this potential difference in a cell? Through chemical reaction. So there is a chemical reaction which creates this potential difference. So now between these 2 points there is a potential difference. So if we connect some load like electric bulb, so the current will flow, like electron will go from here to here. This is the direction of flow of electron, right? But conventional current will flow from here to here, opposite to the direction of current. So now when the current flows through this appliance, right? Current is flowing, so then there is heating effect of current. So in the last class, right? So I square RT. So this bulb will have some resistance. Current flows for T amount of time. It will produce heat. When heat reaches little higher amount, the bulb will begin to glow because it will reach its incandescence. What is that process called? Incandescence. Just check. So when the iron is hot, it starts glowing. First it will be red, and then if it is further heated, it will become white. Okay. So this term, I think if I'm getting it correct, it's called incandescence. You have an agarbatti. What is it called? Incandescence. Candle. The candle is incense. Incense. That's different. Yes. So वैसे ही कुछ है. Just check it out. So when iron is hot, it becomes visible light. In terms of it starts radiating visible light. Okay. So anyway, so what is the difference in AC and DC? This polarity does not change. It is called direct current. So its polarity does not change. Whereas how is AC? Its polarity changes. Like in a second, in 1 second, it changes 50 times. That's why it has a frequency, 50 Hz. So this is one cycle of AC. So like this, there are 50 cycles in a second. Okay. So the polarity is changing above 0. So let's say this is the voltage plus V and this is minus 2. Right? So like this is 230, 220. Up, down, like that. Plus, minus, plus, minus. So polarity changes 100 times in 1 second, right? Twice in 1 cycle and 50 such cycles. Okay? Because its frequency is 50 Hz, the supply which comes in our house. So the appliances are different. So for AC means these devices will not work on cell. You attach a cell, will it start? No. So there are different appliances. So the bulb which you can light with cell, you can't light it in AC means. Try to put it, it will blast. Okay. So you should know whenever you are buying devices, whether what will it operate on? Will it operate on AC supply or DC? Got it. Okay. So coming back to sources of energy, I was saying electricity is the most used source of energy today, like modern times, right? So all these things that we learn falls under conventional sources of energy. Conventional sources of right. Why do we call it conventional? Because it is based on these things. Now, hydro is not a conventional, it is unconventional because every year there is rain, right? So, water is something which will remain with us, but not so if you are producing electricity through thermal. So, electricity can be produced through hydro, thermal plant, or nuclear, right? So, we have three types of electricity generation plants or factories or wherever the electricity is produced. Okay, it is called plant, right? So you can have a nuclear plant or you can have a thermal power plant, right? Or you can have hydroelectricity. So in hydro, we use force of water to produce electricity. Basically, what is the conversion taking place? The mechanical energy of water is getting converted into electrical energy, right? Through a device called generator. In case of thermal, what we will do? We will burn a lot of fossil fuels, coal or diesel or petrol, whatever. Then we will heat water to produce steam. Now you must have seen at your homes through cooker the steam pressure, right? The steam has a lot of pressure. That steam, which we achieved by burning or heating water, by burning fossil fuels, that steam will be directed onto steam turbine. This fan rotor assembly is called turbine. So there are different types of turbine available. This is a water turbine. Then you have steam turbine, right? So the steam will drive this, and then this rotor or turbine will drive the generator. So end device which produces electricity is generator only, right? It is just the mechanism which drives the generator. That's how the electricity gets its name. So thermal mein steam drives. Nuclear mein we carry out nuclear reaction like in BRC. So whenever nuclear reaction takes place, a lot of energy is released. That is in the form of heat only. That energy is then used to heat water, which is converted into steam. Again, steam turbine, and we get electricity. Got it? So when we say nuclear energy for peaceful use, it is this controlled use of nuclear reaction to achieve sustained electricity, right? Now, nuclear energy is very, very efficient. Why it is efficient? Because it does not pollute the environment. Like if you burn, you have to burn so much coal, and that's why this thermal power plants are out of the city, away in some remote corner, and there you will see a lot of gases released in the atmosphere. But the electricity is brought to cities with the help of transmission cables, right? So when we use electricity during usage, there is no pollution. But when it is produced, depending upon what mode is deployed, okay, a lot of pollution is taking place, right? So, this is conventional energy, right? Because when we keep on using this, we only have limited sources, limited reserves, right? So only limited supply is there. That's why it is called conventional. So once it is finished, it takes millions and billions of years for it to get regenerated. Because you know how it gets regenerated, right? The remains of plants, animals, right? Over billions of years, then it will be converted into fossil fuels, buried under Earth's surface through some process, and then we have to dig it out. So have you got the idea? This is called conventional source of energy. So now what do we want? We have a challenge of pollution, right? Our Earth's atmosphere is getting hotter, and therefore we are seeing unpredictable weather patterns. it has become difficult to live. Even in developed country, the weather patterns are very, very unpredictable. And this is in India also. So we are seeing flooding, right? Plus the sea water level is also rising due to global warming, right? So what is happening is this pollution is not letting the heat radiate out of Earth's atmosphere. There are gases available in the atmosphere which are absorbing this heat. Okay. So one is heat is coming from outside and it is not able to escape atmosphere. So it is, that is why it is called greenhouse. So in greenhouse, when we used to increase the agricultural produce or do experiments, what is a greenhouse? That term comes from greenhouse used for agricultural produce experiment, where we take the sunlight in, which is a glass house basically. So it takes the light in, and then the temperature of the cabin, this cabin increases, and that heat does not escape out of the house, because inside comes what do you call the infrared rays. Heat waves are basically infrared rays whose wavelengths are short, but once it hits the cabin, then it re-radiates the infrared waves of longer wavelength, which cannot go out of glass. So the heat remains trapped inside. That's why it is called greenhouse. So greenhouse temperature inside is more than the atmospheric temperature outside, which is suitable for the crop yield. Okay. So this is what is happening in the open atmosphere also. So there are greenhouse gases which do the same thing which a glass house does. Okay. So what are the greenhouse gases? So carbon dioxide, methane, right? All the oxides, right? So such gases. So due to rapid industrialization, etc., we are releasing a lot of those gases. And also during power production, we are releasing and polluting the atmosphere. So all these challenges are there in the use of conventional energy. So you have to make judicious use of conventional energy. Plus, we have to work on the processes of conversion so that they pollute the environment less. So we have to work at both ends, right? So therefore, we have to think of some alternative sources of energy, which we call unconventional energy, right? Or green energy. What is green energy? So making use of solar energy, right? So in country like India, we are blessed with solar irradiance, right? Throughout the country almost. We are not like polar country where no availability of sun, right? So we are working on solar energy. Then the human waste and animal waste, right? All this garbage that we have, that also can be converted into energy with the help of techniques called biomass, etc. Okay. So we have some mechanisms available using which we can convert those waste into productive use, right? And this is something which we create regularly. All the waste is created on regular basis. So if we can find some way of utilizing that waste, so that is a form of conventional green energy, right? Sorry, non-conventional energy. So these are the two things. Conventional is what we are used to. Unconventional is what we are devising. Okay. So you have gobar gas, etc. also. Like, have you gone through this chapter? No. Is it taught in your schools?
No.
All right. So anyway, since I was allocated this topic, I thought I'll run you through this. Hope this was helpful. So in terms of getting the perspective and why we should think of alternative source of energy. Now your doubts from magnetism. How much time did I use in this? 15-20 minutes or more? Okay, fine. Chalo, let's go back to your doubts. So, this is the name of the chapter. Magnetic effect of current drops. Okay. Chalo, who has doubt? Correct. So let me quickly run through it. So I'll bring a wire. You have wondered about how magnet direction of magnet etc. around a straight wire loop. Is it clear? Okay. But we'll check it on the. So first is whenever current passes through straight wire, okay. So, Oersted, right, observed that there is a magnetic field which is created. Let's say this is a wire, okay, and there is a current going in upward direction. Then when a magnetic needle was kept, magnetic compass, it showed deflection whenever the current was going through it, right? If there is no current, where the magnetic needle would point? North-south direction. That is the field, Earth's field direction, right? But when the current is passed, then it showed deflection. That means a local strong magnetic field was affecting it. That is why it was showing deflection. Because magnetic compass will show deflection only in a magnetic field. Okay? So this was confirmed. Now, what was the direction of this magnetic field? Concentric circle in a plane perpendicular to it. Okay? So let's say this is the wire, right? Coming out. So there is half portion below it and half above. You are saying only above portion. So where will be the magnetic fields? It will be concentric circle in this plane. So this plane is perpendicular to the wire. Okay? And what is the direction? What is the direction? Let's say this is the plane and this is the wire. So the current is going up. So we'll apply right hand thumb rule. Okay. So the magnetic field will be concentric circles in this plane, right? Right. And what is the direction of the current? Wherever this tip of the finger points. So let's say this is the point where I want to know what is the direction of magnetic field, right? So I have the wire like this and thumb in the direction of current and tip at the point. So wherever the finger points, so you will notice that it points along the tangent. Right? What is tangent? Always perpendicular. So this field direction will be this. Got it? You know how to use this? You have to, the wire has to between the curled fingers. Only then you'll get the correct direction. Okay. So how do you get this, right? So basically pass the current and use the magnetic compass. You will see it is pointing in this direction. When you mark with your pencil, then keep the compass there and you will see it is marking in this direction. Okay. So when you connect the dot, it becomes a circle. Okay. You keep placing the magnetic compass following the points ahead. That's how the circle would be completed. And it is found that there is a field at every point. So these concentric circles are like, it's not that there is no field inside. Here also if you keep, there will be a concentric circle. Okay. So this is the nature of magnetic field lines inside a straight current carrying wire. Now what is the nature of magnetic field inside a loop? Let's say there is a current going like this. This is the center. This. Okay. Now let's say this is a loop, right? Just see this. Imagine this is a circle. Okay. Now when you see, let's say the current is going like this. Okay. So it is anti-clockwise for you, clockwise for you, and anti-clockwise for me, right? So if it is clockwise for you, so this is the direction of current. Where is the finger pointing? It's towards me, inside. So it should be S, South Pole, right? You are familiar about the magnetic field in case of the bar magnet? You are familiar about. So field comes out from North Pole and enters into South Pole, right? So field always comes out from North Pole and enters into South Pole, outside the magnet, and within the magnet it is south to north. You know this, right? This is how the nature of field is. Right? And what else? Field lines do not intersect each other. Why? Because at every point it has a unique direction. It's a vector field. It has some strength as well as direction. So it has magnitude, like say 5 Tesla, right? So 5 is the magnitude 5 Tesla and direction will be, let's say this is whatever. In this plane, this is east, this is west, this is north, this is south. Okay, in this plane. Accordingly, you can tell the direction also. So it will have unique direction at every place. But if the magnetic fields are intersecting, right, at this point, so what is the direction? Will you take this tangent or will you take this tangent? Which tangent will you take at the same point? Okay, so a curve cutting has two tangents. So there is a violation. You can't have two directions because it has to be unique, well-defined direction. Okay, so that's why magnetic field lines cannot cut. So here, so what happens in this case? Tell me, what is the pole now? North. It will be north. Why? Because so you do when you take this wire along the fingers, then you'll have this fields coming out. Okay, dot dot dot. So how to remember? You draw a north pole like this. Align the directions. North. So what is this? Anti-clock. So whenever the current is flowing anti-clockwise, the front face would act as a north pole, and the back face would act as a south pole. So a coil, this current carrying coil is the smallest magnet. Got it? Any current carrying coil is a smallest magnet because if the front is acting as a north pole, the back will act as a south pole. Okay? So the back of this, if I see it from behind, how will it look? It will look like this, clockwise. And therefore, the field direction is inside. Cross means the tail of the arrow, right? The feather looks cross. Point means the front of the arrow, which is a tip. So it is coming out, right? So this is a sign convention. So this is like field is going into the page. This dot means field is coming out of the page perpendicular to the plane of the page or board. Okay. So which pole is this? So this is all. So align the direction, right? So, okay. So now we have solenoid. So any questions here? All clear, everybody? Feel free to stop me and ask. Don't get intimidated by the speed with which I am going. Okay, stop me just in case you have any doubts. Now, what is a solenoid? Solenoid is, yeah. So let's say you have this. So how many turns are there? So when we have so many turns now, right? What we get is a spring-like structure. Okay. So each turn is a loop, current carrying loop. So we have 1, 2, 3, 4, 5, 6, 7, 8 in this case. So now, are these loops touching each other electrically? No, there is an insulation. Okay. So in solenoid also, these are all individual loops. So each loop is a magnet. So if the magnetic strength of one loop was 1 Tesla, let us say. So if it is 2, 3, 4, 5, 6, 7, 8, it will be 8 Tesla. Right? They will all produce magnetic field in the same direction, right? Let us say this is how the current is entering. This is the direction of current. So how will be which will be north pole and which will be south pole?
This will be north, this will be south pole.
This will be north pole.
Yes.
How?
So the current is going like
Current is in the thumb direction.
yes.
So where is the finger?
Right.
So this is south.
This is south.
Okay. You have to note two things. In a solenoid, so this is called core, on which the wire is wound. Okay. So this core could be a plastic or it could be a magnetic material like a soft iron core. Right. So plastic is only taken for the or to be able to wind the wire. Okay. Now, so whenever the wire is wound in a helical shape like this, where the length of it, this whatever geometry is obtained, when the length is bigger than the diameter. Can you see the diameter of the loop? When the length is bigger than the diameter, then we call it solenoid. Okay. So wire wound in a helical shape in this fashion is called solenoid, right? So two things to be observed. This wire, on one end it is on the front, on the other end it is behind. That's very important. So whenever there is a diagram given in your question paper, so one end of the wire is behind and the other end is in front. Okay, so see it very carefully, right? Because in determining the current direction, it's very important. Now see, so here the current direction is upward in every loop, but here it is downward. It's upward here, but here it is downward. Okay, so if it is downward, what was your rule was when applied on this end it was like this, but at this end it will be like this. Okay, so this is north and this is south. Clear? So only this has to be noticed. Okay. So questions are basically to identify, a diagram will be given, will be asked to identify the north and south pole. Okay. So this is it. Then you have Fleming's left-hand rule, right? So we are done with right-hand thumb rule. What does this rule gives? Nature and direction of magnetic field. Yes. Magnetic field through current carrying wire and coil. Or okay, so everywhere we have used right hand thumb rule only, or if you have a solenoid. So solenoid, how do you draw? This is how you draw. Right. So if the current is entering from here, so everywhere it will be out. Be very careful. Now tell me which is north pole and which is south pole. So it is gone from behind and then come out from front. Okay, one end behind, left end is behind, this is in front. Or if this was in front, so how it will look like? Now see, suppose this is how it is. Now the wire will come like this. So you should expect diagrams like this. Can you see? Okay, these are the two diagrams. There is no third person. Tell me the polarity. So this is clockwise. Clockwise is south. Anti-clockwise, and this is anti-clockwise. Can you see how the polarity changes? Okay, this is how you do. Now solenoid and bar magnet field patterns are exactly same, right? So if this is south pole, so the field enters from here, it comes out, right? It is like this. So the field of solenoid and bar magnet is exactly same. What is the difference? What is the difference between field in bar magnet and solenoid?
That solenoid relies on electric current, whereas bar magnet is independent.
So bar magnet, the field is fixed. You cannot vary it. Whatever is its strength, constant magnetic field. Here you can vary. You can vary the magnetic field strength by increasing the current through it.
And coil number of turns.
Yes, number of turns also. right? Because I told you, each coil is a magnet and they are all producing magnetic field in the same direction. So it will get algebraically added. Okay. So this is like electromagnet. Okay. So there are three ways in which you can increase its magnetic strength. How? What are the three ways in which you can increase the? One is by increasing the magnitude of current. Second, by increasing the number of turns. Third is increasing the current. Current flow turns. Two. What is the third one? By inserting a magnetic core, soft iron core. So then it will concentrate more magnetic field. Okay. So if you insert soft iron core inside, then its magnetic field strength will further increase. Okay. So all these things. The moment you switch off the current, it is no more a magnet. So you have no way of controlling your natural magnet, natural bar magnet. It remains magnet. It's a permanent magnet. Whereas this is not a permanent magnet. It behaves as a magnet only when you want it to. Okay. So there are many useful applications. Right? So this is all about solenoid. Now we will come and discuss about what's the time now? We still have 20 minutes, right? Okay. So force acting on current carrying wire in magnetic field. Right. So let us say we have a, let's say this is north and this is south. We have a horseshoe magnet. Right. So this is a part of the horseshoe magnet. We are not saying like in the diagram of motor. So what is the field direction now? It will be like this. Okay. And now we have a current carrying wire. Let's say there is a wire in which current is flowing from A to B direction. Everything is in the plane of the board. Okay. Then this wire will experience force. Why? Because a current carrying wire also produces magnetic field around it, right? And it is also kept in a magnetic field. So those magnetic field will either attract or repel. And by virtue of that, this wire will experience force, right? So that force is given by a law called Fleming's left-hand rule. Right? Let's say this is the direct law. So what is Fleming's left-hand rule? So this indicates magnetic field. So field. Right? This indicates motion or force. Okay. And this, what is coming out? It is the direction of current. And all of them are perpendicular to each other. Imagine the corner of the room or your notebook. Can you see this? X, right? Y, Z. Okay? X, Y, and Z, like that. So align it like that. So everything is orthogonal, mutually perpendicular to each other. So in this situation, what is the force? What is the direction of force on the wire? Behind. So you have current. So align current and field, right? You align current and field. This is field. So it goes perpendicular into the plane of board. Okay. So the force direction is inside. Got it? So you can align. This is field direction. This is current direction. So align current and field. So there is some inside the board. Got it? This should be easy. So that's it. If you have any other question, what else is there in the chapter? So Fleming's right hand rule is not in the syllabus. So, okay, can you tell me this? Where will be the force acting on this situation? Look at activity 13.7. Is it given in the volume? So this is the application of Fleming's left hand rule. So it's very important activity 13.7. So you have a rod. So this is the conductor and it is placed in the magnetic field like this. So this is north and this is south. Okay. So how is the conductor placed like this? And then the current through it is traveling in this direction. Right. So what does it mean? Right. So this is what it is. So how is the current? It is coming in this direction, right? What is the field direction? North to south is up. Field is going up. Right? So this you have to understand that this is like coming out of the board. It's like this. Okay? What is the current direction? What is the current direction? Towards you. It's like this. Okay? Current apni taraf aa raha hai. So this is current. What is field direction? So the rod will be left. Okay, right to left. Isn't it? Read the activity. So in this direction, what is shown in the figure, this rod will move from right to left. See, what is the field direction? Up. Current is towards you because this is like ये magnet ना ये कैसे है देखो ऐसा this orders. There is a stand here on which this wire is hanging. Okay, okay. This wire is hanging. So the current is coming towards you, and this is north pole. This is south pole. So north to south. So U magnet. So north polarity to south polarity. Always magnetic field. So between these two poles, the magnetic field direction is upward. So then तुमको क्या मिल गया? You have a current direction and you have a field direction. So left hand rule लगाओ. Current is this, field is up, thumb is left. तो इस पे force कहाँ लगेगा? ऐसे. Read the activity. है नहीं उसमें? Time कितना है? 10 minutes है ना? I'll just try to download. और कोई question है तब तक देखो. Do you have any other question? Yeah. Okay. No browser. यहाँ ये वाला क्रोम नहीं है क्या इसके अंदर? नहीं ये सब क्या हो गया? Give me browser. So we have, what is it? 10 CBSE. Physics. क्या लिखना है? PDF.
PDF.
ये क्या हो गया? ये तो सिलेबस ये है क्या? ये वाला। Which chapter is that? Not found bad website. चलो ठीक है. So yes, sir. Should we try this? Okay. Which page is this? 230. So this is how you draw the field lines, right? आप यहाँ पे एक जगह पे कंपास रखो फिर उसको डॉट लगाओ जहाँ पे नॉर्थ पॉइंट है फिर नेक्स्ट टाइम कंपास उस पॉइंट पे रखो एंड जस्ट फॉलो इट देन यू कनेक्ट द डॉट्स ऐसे फील्ड लाइंस मिल जाए. Likewise, when you have a glass board on which iron fillings are sprinkled, keep the bar magnet and tap the board. So these iron fillings will arrange it in the direction of magnetic field. Because metals are attracted along the magnetic field lines. This pattern will resemble. So field lines are available everywhere. This is how you get it from here, right? Whereas here it shows only few lines. Doesn't mean that there is no field line between the empty space. There is field line everywhere. Then here how it is reflected, right? Initially, when you keep the compass without passing the current, okay, it will be pointed in north-south direction. But when you pass the current, what happens? So it will be deflected. That's why the arrow is going right. Okay, the compass is kept below the wire. Okay, and when you change the direction of the wire, now the force is left side. Okay, original direction is this. Okay, this is how the deflection is taking place. Is it clear? See, this is the plane. So if the wire is going like this, concentric circle clockwise. And this is the same thing. If the iron filings are sprinkled, gently tap after passing current. These are all concentric. Right. So these are all activities. There may be questions on activities. This is a demonstration of right and thumb rule. This is how through a coil, right? Magnetic field coming out through a coil. So the coil is perpendicular to the board. And how is the current? Current is entering and it is coming towards you from the upper end. Okay. So over here, which is up and which is down? The right side is going towards below. So this is, so here, so this part, the copper shirt thing, right? The bold one, okay, is outside the plane and the shaded one is inside. So the current is entering from behind the plane. It's like this. Now that it's like this. It's like this. So only half part is towards you. This part is behind. Okay. So you have to judge the direction carefully, and that's the only skill you require, only experience. And, coming to the activity. So everywhere it is like that. You should be able to answer now. Where is the activity? Can you all read this? So this is coming towards like this, north and south. So now pass the current through aluminum rod from B to A. Okay, what do you observe? It is observed that the rod is displaced towards left in the book. Okay, reverse the direction of current flowing through the rod. Now you pass the current from A to B. So then what happens? So this was like this. Okay, then it was going towards left. Now magnetic field direction is not changing. Okay, when you reverse the direction, the current will go inside. So now it will be inside. Okay, it is now towards the right. Clear? So that's it. What else we have in this chapter? So this is the Fleming's left-hand rule, already explained. Can you answer this question? So there is a magnetic field traveling from left to right. Okay. Now the electron, right? The direction of force acting on the electron will be. This is how the electron is flowing down. So what is the direction of current? Up. Okay. So whenever you apply the right-hand Fleming rule, you will take the conventional current direction, not electron direction. Is it clear? So field is this and current is up. So the force will be into the plane of the paper. So answer is D. Apply करो ना तुमने तो सही बताया. See, Fleming left-hand rule. Magnetic field. This is magnetic field. Now this is when the electron is flowing down. So where is the current? Up. Where is the current? So ऐसे करो ना, ऐसे. Field this way, current up. So where is the thumb? Into the plane of paper. Okay? So into the plane. The direction of force is perpendicular to the direction of magnetic field and current as given by Fleming left-hand rule. Now this recall that the direction of current is taken opposite to the direction of motion of electron. So this is a very tricky and popular question. It generally comes. Okay? The force is therefore directed into the pitch. Okay. Don't leave this in-text questions. Huh? These are all very important. That's it. Now electric motor is not in the syllabus. You have different advantages of AC over DC. Is that clear to you? So what are the 3 points you can tell me? What is the difference or advantages of AC over DC? AC voltage can be increased or decreased. DC cannot be. Just like bar magnet, which is permanent, electromagnet, which is flexible. AC where you have a flexibility. Like you have 230 volt coming here, but you can power computer also, which operates on 10 or 12 volts only. So 230 volt is converted into 10-12 volt DC before the power enters the computer. So the changing of voltage is possible in AC. Okay, that's not possible in DC. What else? AC voltage can be transmitted over longer distance. DC cannot. पूरा cell लेके जाना पड़ेगा. Okay. So through the wires, all the wiring throughout the society everywhere, it is AC. DC को तुम ऐसे transport नहीं कर सकते. Okay. So these are the two things. Then what is the difference? So yeah, so DC is not fluctuating, AC is fluctuating. So fluctuating as in Is this fluctuating? So AC is fluctuating, but we derive the application out of its heating effect. Because what is heating effect? I square RT. So if it is squared, then polarity does not matter. Minus or plus will always give same amount of heat. So all the devices of AC are based on heating effect. So polarity doesn't make it dance, right? Fluctuating is because of other reasons. Okay. So वो difference नहीं, ये दो major difference है, ये तो लिख देना. और क्या है? House wiring you are clear? Live, neutral and all. So that's it. खाली AC और DC syllabus में है, लेकिन book में नहीं दिया हो. Is it given? Motor, generator, everything, nothing is in the syllabus, right? So there is difference between AC and DC is given on page 237. Just write down here. This para. Page 237, this para. First para. Okay, that's the difference between AC and DC. Okay. Page 237. Just make a note. 237, first page, first para. So you can read the difference between AC and DC and the things that I told you. So I think we will now be meeting only for extra lectures, right? What have they told you? Have they told you anything? Okay, so we'll see. So you can demand an extra lecture if you need more doubt clearance. But as far as we are concerned, the physics syllabus is completed for you. Okay. So I wish you all the best. Happy studying.